Powerhand VRS transforms the moment a worn-out vehicle rolls onto the concrete pad into a precise ballet of dismantling. Hydraulic jaws adjust automatically to the car's frame, securing it in place before the robotic arms glide forward. Each limb is equipped with sensors that map the vehicle's contours in real time, ensuring every bolt and wire is reached with surgical accuracy. The system's integrated cameras feed a live 3D model to the operator's console, where minimal oversight suffices. Within seconds, the first latches release, and the hood lifts on its own, revealing the engine bay for the next phase of recycling. Internally, the Powerhand VRS prioritizes fluid management with a dual-stage containment system. As the vehicle rotates on its turntable, high-precision drills puncture seals on oil pans and coolant reservoirs. Drained liquids funnel through color-coded hoses into recyclable containers below, preventing cross-contamination and environmental hazards. Automated valves close within milliseconds after flow completion, and the entire process is monitored by chemical sensors that confirm purity levels. Technicians receive real-time alerts if any fluid deviates from safe thresholds, ensuring compliance with local regulations without manual testing. This end-to-end automation slashes cleanup time from hours to mere minutes. Once fluids are accounted for, the VRS begins its modular disassembly sequence. A combination of magnetic wrenches and laser-guided cutters detaches doors, bumpers, and wheel assemblies in a choreographed routine. Each removed part is automatically placed onto designated conveyor belts, where laser scanners verify part numbers and direct them toward refurbishment or salvage. The system's AI compares incoming components to a database of recyclable assets, determining which pieces can be resold, which need reconditioning, and which must be recycled into raw materials. This intelligent sorting reduces human error and maximizes the value extracted from every vehicle. Powerhand VRS integrates a high-capacity shredder for non-salvageable metal frames. After the modular parts are removed, the remaining shell moves forward on the same turntable into a heavy-duty crusher. Hydraulic pistons fold the steel frame into compact cubes, which then drop into a collection bin below. These cubes are sized to industry-standard dimensions for seamless transfer to steel mills. Dust suppression nozzles spray a fine mist during crushing to capture particulate matter, ensuring worker safety and reducing airborne pollutants. The result is a perfectly prepped batch of metal ready for smelting and reuse. Safety protocols in the Powerhand VRS are governed by advanced motion capture arrays. Infrared and LiDAR sensors surround the entire workstation, creating an invisible safety cage. If any human enters the danger zone, the system halts instantly, joints lock and hydraulics disengage to prevent accidents. Operators use wrist-worn tags to bypass the safety cage when maintenance is required, shifting the system into manual override mode. Each maintenance action is logged automatically, and predictive analytics flag any recurring faults, ensuring continuous operation with minimal downtime. Behind the scenes, the vehicle recycling system software suite orchestrates scheduling, parts inventory, and compliance documentation. As each vehicle is processed, the system generates a detailed digital report, part weights, salvage values, fluid volumes, and environmental impact metrics. These reports integrate with the company's ERP platform, automatically updating stock levels for used parts and ordering raw material pickups. Real-time dashboards display throughput rates and identify bottlenecks, enabling managers to adjust shift patterns or machine parameters on the fly. This end-to-end digital linkage transforms data into actionable insights, boosting operational efficiency. Powerhand VRS accommodates a wide range of vehicle types, from compact hatchbacks to heavy SUVs. Adjustable clamps and telescoping arms adapt to wheelbases and chassis heights automatically. A software calibration routine runs at the start of each job, measuring wheel diameter and track width, then fine-tuning gripper positions. The system's adaptability extends to electric and hybrid vehicles, where additional wiring harnesses and battery packs require specialized removal algorithms. High-voltage systems are isolated within a sealed chamber before disassembly, and safety interlocks ensure zero exposure risk. This versatility makes VRS a one-stop solution for recyclers handling diverse car fleets. Maintenance is streamlined through predictive wear analysis. Embedded vibration and temperature sensors on critical joints feed data into a cloud analytics engine. The system forecasts lubricant breakdown, seal fatigue, or hydraulic fluid contamination weeks in advance. Scheduled maintenance alerts appear automatically, and spare parts are reserved in inventory just before the predicted service window. This reduces unplanned stoppages and extends the lifespan of expensive robotic arms and hydraulic components, saving time and maintenance costs. Energy efficiency is another hallmark of Powerhand VRS. The system employs regenerative braking on hydraulic motors, capturing kinetic energy during deceleration phases. Stored energy powers secondary systems like dust suppression nozzles and internal conveyors. Solar panels mounted on the workshop roof feed directly into the VRS's power bus, offsetting up to 30% of its electricity needs. Energy use reports show a net reduction in operational costs and carbon footprint compared to traditional dismantling lines. This focus on sustainability resonates with companies aiming to achieve green certifications. Throughout the day, multiple cars queue for processing, connected by an overhead rail system that optimizes floor space. The VRS can handle one vehicle every 10 minutes, translating to 6 cars per hour. Real-time scheduling software routes each chassis to the next available station, balancing loads across multiple VRS units if present. This modular scalability allows facilities to expand or contract capacity without major redesigns. Operators simply add or remove VRS modules and adjust software parameters. The result is a lean, high-throughput recycling operation. Training for new technicians is accelerated with an augmented reality (AR) interface. Trainees wear AR glasses that overlay step-by-step instructions onto the VRS machinery itself. Virtual annotations highlight which cables to disconnect and where bolts are located, reducing learning curves from weeks to days. Performance metrics, task completion time, error rates, and adherence to safety protocols are tracked automatically and fed back into personalized training plans. This digital-first approach ensures that human operators become power users of the VRS very quickly. Integration with end-market channels is seamless. Refurbished parts flagged by the VRS are automatically listed on online marketplaces via API connections. Bulk metal cubes are scheduled for collection by steel mills through the same platform. The system even notifies logistics partners when vehicles containing hazardous materials require specialized transport containers. This level of connectivity shortens lead times for both buyers and recyclers, creating a closed-loop supply chain that delivers recycled materials back into manufacturing efficiently. Looking ahead, Powerhand VRS designers are exploring full autonomy with mobile VRS units that can be deployed to remote scrapyards. Solar-powered crawler tracks and fold-out shelters would allow off-grid operation, bringing advanced recycling capabilities to underserved regions. Machine learning models are being trained on diverse vehicle datasets to handle legacy car models from the 1980s and 90s. With continuous software updates delivered over the air, each VRS remains current with the latest protocols and part catalogs, future-proofing investments in sustainable vehicle recycling. In every aspect, from mechanical precision to digital integration and environmental stewardship, Powerhand VRS represents the next frontier in vehicle recycling. It elevates car dismantling from manual labor to a high-tech, data-driven process that maximizes value recovery, ensures safety, and minimizes ecological impact. As automotive fleets evolve toward electrification and shared mobility, systems like Powerhand VRS will be essential for turning end-of-life vehicles into resources for tomorrow's mobility solutions.